Hello everyone. Today is the 15th day of Leetcode 75 challenge. Let's begin with the 15th question. Question number 1456. Maximum number of vowels in a substring of a given length. And the level of the problem is medium. I will request you to read the question beforehand as I will deep dive into the PPT and explain it in simpler way. Now let's understand the problem in the easiest way possible. So you have been given a string S and an integer K. Now you need to find a contiguous substring of length K that contains the maximum number of vowels letters. Okay. And what is a contiguous substring means? The characters in the substring appears consecutively without any gap, and the length of the substring must be exactly k. Okay. And we have tasked to return the maximum number of vowels letters in any substring of s with length k. So basically, they're trying to say that you have been given a string a, b, e, I, o, s, d, and then k length. So which contains the maximum vowels of letters. So basically, k will be the substring, and that will be contiguous. Contiguous means there would be no gap between A and E or A and O. Since even though we are maintaining the relative order, there could not be any gap. There has to be continuous. And within that bracket of K length, we have to count how many vowels are there. In this case, we have A and E. So we have two vowels in this case, right? And this way we have to find out which substring has the maximum number of vowels present in it, right? And the length of the string will be from 1 to 10 to the power 5, and S consists of lowercase English letters only. And the K would be from 1 to length equals to the length of the S. Okay, so I hope you understood the problem what we have to do here. Now let's move to the next slide. Let's understand the input output of the problem. So you have been given an input A, B, C, I, 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 D, E, F. And the length of the substring would be only 3. Fine. So let's take substring of length 3, BCI. Here vowel is I, so count will be 1. Now let's take another substring. Let's take IDE. Yes. Now we have got the count as 2 because there are two vowels I and E. And and since the answer is 3, we could also see that there are 3 I's consecutively present here. If we take these 3, we get count as 3. So this is the maximum number of vowels present in a substring of length K. Right? This is what the question was asking us about. Now let's understand this problem also. Here A, E, I, O, U. Output is 2, and and K is given as 2. Fine. You can see that all the characters in the string is vowels A, E, I, O, U. Fine. And the length of the and it's common sense that if the complete string is of vowels and K is whatever the length of the K is, it will be the answer exactly. Why? If we take this substring of length 2, we get 2 as the count of vowels. If we take this, we get 2 as the count of vowels. Even if we take this, we get the 2 as the count of vowels. So it does not matter because since the complete string is made up of vowels itself, so if whatever the value of k will be, it will be the answer. That's why the output is 2 in this case. I hope you understood the input output explanation. Now let's move to the next slide. To understand what the problem is asking, we should build up an intuition to the problem. Now let's imagine you are playing a game with vowel tokens and you are given a long strip of tiles, and this is basically a string S, and each tile may or may not have vowel on it. Okay, so you have been, let's assume that you have been given tiles. Okay, and our goal is to find the set of k consecutive tiles that contains the most vowels. Okay, so now they have given us to find the number of vowels in a tiles, right? Assume it's this way, and it has been said that the length of the tiles you can take in hand is 3, and it has to be contiguous. Fine. Now a person will be thinking that if I can take a k number of tiles in my hand, and it has to be contiguous, so he will come he or she will come and he will take first three tiles in it, right? Now let's assume that it contains A, E, C, I, let it be I, and C, D, U. Just take some, let it be B, C, B, U. Okay. So he took first three tiles and he said that I got two vowels in it. Okay. He is correct. He got two vowels in it. Now, another thing in terms of our intuitive mind, intuitively thinking about it, that we can go for the next three tiles. Yes. In this, we got two, sorry, CPU, one. But we missed something here. We missed what? There is another combination of EIC, right? And ICB could also be taken, right? And CBU, we took CBU, right? So there we missed some of the combination of tiles now. Okay. So first approach which we tried to took was nearly correct, but it was not considering all the tiles or combinations of tiles. Now the person knows or we know that we have to take first three tiles. It is necessary because you cannot just go in between and take tiles and come back. For example, if we think like if we take three tiles here, then it will be a hard task for the person to go back and make another combination, then come ahead, make another combination. It's a tedious task to do, right? Instead of that, we will start from the beginning only. Fine. Okay. So we have taken the three tiles beforehand here. Now, a person has three tiles in his hand. Let this is with three tiles he has in his hand. Let this be a hand. Okay. He had three tiles. Now what he can do, what he or she can do is that he knows that all in one he have to have three tiles in his hand and they has to be continuous. So what if he takes this slide, the person takes this slide, tile, sorry, he have this tile in in its hand, but now the issue is that he have four tiles in his hand now, right? What if we throw this tile out? We throw this tile out. Now what we got? We have three tiles, which means we already had these three tiles A, E, I. Now he included C also. If he included C, what happened is that the number of tiles in his hand grows to number four, and now he have AEIC. But he thought that I will remove A also, A from my left hand. So he removed A and he's left with EIC. Now he checks that still he got two vowels in his hand, right? And it is also maximum till this case now. So I hope you understood what we're trying to do here, right? If you go to the points and if you check, count how many vowels are in his initial window, like the first initial window which he takes. You can put in look into it more thoroughly. They're basically creating windows here. This is one window. Just imagine a window which could slide. Okay, this is one window. Now you slided this window towards this side. Now this window came from it started from E to CN. Again you slided the window. It went from I to B and similarly from C to U. Right. I hope you understood that this is kind of a sliding stuff we are doing in this case. So yeah, so this first case we will just check how many vowels would be there. Yeah, that could be our first intuition. We took a window of k size and we check how many vowels are there. Now this is our starting score because as we go further, there could be multiple vowels or maximum or minimum vowels could be there, right? Now we slide through the strip. We move forward one step, adding a new tile from the right. As I said, the person takes one tile which is ahead of the which is basically fourth tile. We could just consider as a fourth tile, just C in this case. He will take in its hand and we will drop the leftmost tile, basically the left tile or the tile which is in his left hand. He will drop that tile. Again, the window size will become 3 or the number of tiles in it that become will 3, right? So, one more thing you have to take in consideration in here is that the person has to check when he is throwing out the tile whether it is a vowel or not. This is a very important thing. because we have to keep the count, right? How many tiles we are coming get putting in and throwing out. So first he took these three tiles and he counted that okay, we got these two vowels in our case. Now he moved ahead. Now before moving ahead, he had to check three vowels. As I was saying, two vowels. Actually, it was three vowels: A, E, I. Fine. Okay. So before throwing the vowel or the tile, he or she will check whether the vowel which I am throwing, let the count be three, because initially when he counted the count was three. He will check if I am throwing a vowel, then I have to reduce the count, right? And I'm moving ahead, and if the value which is getting entered here, if it is a vowel or not, I have to check that also. If it is a vowel, I will add one, right? This is a thing which is most critical point in our intuition. So our intuition comes up to a part that where we are trying to slide the substring as a window towards the right side. Then we are checking whether the tile which we are throwing, the person who has the tile in his hand, whether which the thing in his hand, if it is throwing it, whether it is a vowel or not. If it is not a vowel, we won't be touching the count because it is not a vowel, right? We are still the vowels are present somewhere in our window. And if the incoming vowel is there, we will increment the count, of course, right? If it does not, we will keep the count as it is, right? That is the point which is written here. If the removed tile is a vowel, decrease the count. If the new tile is a vowel, increase the count. We have to keep the track of the highest vowel count, which can be done by storing it or writing in some paper for the user that current count is three. Now the max count came out to be two or one, whatever it is. Fine. Now return the maximum count of vowels in any K length window. Right. This is the intuition. And now from the intuition, if we can figure out that this is a question of an sliding window technique. The sliding window technique is one of the most important topics in solving this kind of questions. And if you could see, we are just creating a window here and it's sliding towards right? So this is the intuition of the sliding window technique, and I hope you understood this intuition. Now let's move to the next slide. Before going to the approach, let's understand what is sliding window concept in more deeper meaning or in more deep depth, right? So sliding window is a powerful technique used to efficiently solve problems involving contiguous subarrays or subsequences. I hope you understand what is subarrays, right? If this is a subarray with some values, the subarray for it will be x, n, z. We follow the relative order given in the original array, but it may be continuous or it may not be continuous. Fine. And same case in the case of string also. Now how it works? First, we define a window, usually a fixed size of k or dynamic size. Window could be a dynamic size also, or it could be of fixed size also. Uh, that could be derived from the question itself, what the question is asking, over a part of the array or string. Now, we just start by calculating the result for the initial window. Now, whatever the calculation has to be done for a particular window, like adding the complete value, taking the average of those of that window, taking the multiplication, or anything whichever is asked in the question. Then slide the window one step at a time. Add the new element coming to the new window, which is in the right side, and removing the old element that is leaving the window, which is from the left side. Now keep updating the result while sliding. So it goes like this is the array, and this is one window from start to k size. Now your task is we will add new element, that this will be the new element added, and you remove the last element. Let this be the last element removed. So our array just moved by one, right? This is how it goes. Now, why is it efficient to use? Now, instead of recalculating the result from scratch every time, we just have to adjust the result using a new and outgoing element. Just requires O of n time in that. And the total complexity becomes to O of n instead of O of n into k, which you get from brute force approach. Brute force approach is basically start from I, go till n, k, this is the size. Then again you start with I plus 1, and again you go from k times, and this is how you go, right? So this boils down our complexity to O of n. Now let's move to the next slide. Now, variations of the sliding windows. Now, where could you use the sliding windows and what could be the variations of it, right? So let's understand that also. If it is a fixed size sliding window, if the size is given to you, it is fixed that it will be a k of suppose size is always 5 and it won't be changing. So just have 5 and sliding one step at a time and adjusting the result. Use cases could be maximum, minimum, or sum of fixed length subarray. Example is maximum subarray, maximum sum or average of subarray of size k. Now there could be a two pointer variation also. The left and right pointers define the window here. Expand or shrink based on the conditions, like finding pairs, minimum, maximum range. Example could be container with most water. We solved this question in our previous videos. Please look into those also regarding the two pointer variation container with most water. The third type or third variation will be monotonic sliding window. We use a DQ to keep elements in order while sliding. DQ is a data structure in a nutshell is that we can push and pop from back, push or pop from front. Right? This is DQ. The use case could be maintain a sorted or maximum minimum values in a window. Maximum in each subarray of size k. Whenever you have to maintain a sorted maximum or minimum values in the window, we have to use DQ, and this is called a monotonic sliding window technique. Now the fourth variation will be dynamic size sliding window. We expand the window until a condition is met. Shrink if it is violated. Now, expansion of the window is done from the right hand side and shrink is done from the left hand side. Right? If we expand it like this, then you shrink it from the back this way. The use case is longest or shortest substrings satisfying a condition. Example could be of the problem longest substrings with k distinct characters. Now the fifth variation will be circular sliding window. Window wraps around an array boundaries like a ring. The array becomes a ring. Fine. Use case would be sum or minimum maximum in a circular arrays and maximum sum of circular subarray. So these are some of the most commonly used variations I have defined here of the sliding window technique. I hope you get a gist of sliding windows and their use cases and examples of the problems I have mentioned here. If it is good to you, please go and look at these examples and you can understand how these sliding window techniques are being used. Now let's move to the next slide. Now, where sliding window is used, okay, in a nutshell, if you see in subarray subsequence problems, like having maximum, minimum, average of size k, longest, shortest subarray satisfying a condition. In string problems, longest substrings without repeating characters, longest substrings with k distinct characters, and minimum window substring. Now, pairing and range problem also. Container with most water, sum of two elements closest to zero, number of subarrays with some within a range. Now, frequency counting using set or hash map. Longest substrings with k most distinct characters, find anagrams in a string. Now, I have given you the sliding windows where it is being used here, and these are some of the examples or name of the problems. I have given you the names of the problems and examples where this sliding windows is being used. It is just a gist. So you could go and look at this the problem and understand that how the sliding windows are being used in this kind of problems. I hope you understood the concept of sliding window, how it is, how it works, what are the variations of the sliding windows, and what are the problems. You could look into it, just get the understanding and gist of sliding window and where the windows are being used. Now let's move to the next slide. Now, since we got the intuition of the problem, let's look into the approach, how we're gonna solve it. Fine. Now we have the understanding of the intuition and what is the concept of sliding window and how the sliding window are being used or implemented. Now let's deep dive into the approach more clearly. Now we will initialize the variables count, result, vowel, and n. Now here, count will store the maximum number of vowels in the current window of size k, and result will store the maximum number of vowels found in any k length window, right? Because count will store the maximum value. Fine. The total maximum value till now we got is this. But result will store the current count of the vowels in the particular k size window. And vowels is basically is a variable which is a set containing five vowels for quick lookup. Now, why we are using a set here? Because we know that there are only five vowels in English alphabet, right? Which is A, E, I, O, U. And if you take the complexity of storing this vowel as it is a constant and not dynamic, it is O of 1, fine, or O of 5, which is also constant, fine. Now the thing is, the lookup of vowels instead takes an average time complexity of O of 1 in this case, right? That is the reason we have to check somewhere whether the character is vowel or not. So this is one of the easier way to look into it, fine. Now, okay, now we stored length of string in n just for our iteration purposes. Now there could be a edge case where k becomes greater than n. Now, the given k value could be greater than n. Now we should keep in our mind that if you are finding out a substring, substring is a part of the original string. If an original string is of length n, which is for supposed to be 10, and k comes out to be 11, this is impossible because substring is a part of the original string itself. A substring would be from length 0 to n. Fine. But if k is itself greater than the n, it is no match, right? So k has to be always smaller than or equal to n. Then only we will be able to search for a substring. So this is the edge case you have to handle here. Now coming to the step 3, we create an initial window. Now why we are creating the initial window is that we're iterating over the first k characters here. Fine. For example, suppose you're given a string as A, E, B, C, D, Y, X, O, U. Fine. Now we know that K is of length. Suppose here in this case, let it be 3. Okay. Let me write it here. Suppose in our example here, let's K is equals to 3. Here, what we are basically doing is pre-computation. Before going to the main iteration of the sliding window, we just go ahead and iterate till with K equals to n, with K equals to 3. And we store the count of the vowels in it. In this case, count is AE, right? So it is 2. Now, how this help us is that when we'll go for the sliding window technique, we will be starting from there. I will be started from here because we know that we have the previous count of vowel with us. And it will make this easier to calculate the upcoming counts because we have stored the count of the vowels here until this window and now I is starting from here. So it will be easier for us to shift the window ahead. Because if we have not done that, then we have to take two pointers to solve it. And it could be a bit of tedious task because we will put I here and J will iterate till B, which is equals to K. And then we will have the count while looping it. Then again, we will place I here and J will be pushed here. So it's bits of a confusing kind of a thing. So rather than following that, it, we take the iteration of the first K characters and count their vowels beforehand and it makes the code also much simpler to understand. So that is the reason we do the iteration of the first k characters beforehand. Now in this case, suppose we have count equals to 2 and k is 3, so we have the iteration till here. Now iterate from index k to n minus 1. Now we will start from k. K means I will be starting from here, which is if we go for index based, this is 3. C is in index 3, which is the value of k, right? And we will remove the leftmost characters. As we remember, the person having the tiles in his hand throws out the tile which is in its left hand. And here we are doing I minus k. Now how this I minus k is derived is that I minus k basically throws out in every time, it throws out the first character of the window or the first index of the window, not the array of the window. Now I is, in this case, we have 3 and we know k is itself 3. We get 0. So S of 0 will be removed, which is what we want, right? When we shift from AEB to EBC, we have to remove A, which is in index 0. So it will be removed. Now again, After removing this, I becomes I was in 3, right? So I comes here, I becomes 4, right? Now 4 minus 3 gives me 1. Now in this EBC window, if you can see, E is an index 1, so it will be removed, right? And the window will be BCD. So this is how we will keep on doing and removing the first value or first index value from the window. And when we add the new character, we will just see if it is a vowel, right? We have to check if it is a vowel or not. If it is a vowel, we increment also the count, right? But when we are throwing out the character here, we have to check if it is a vowel or not. If it is not a vowel, no, we will don't touch the count. But if it is a vowel, we have to decrement the count because it has been removed from our window. Fine, and we will update the result variable with the current count of the window and the previous result which we had, and we will take the maximum from it. Okay, and after doing all this iteration and sliding window, at the end we will return the result variable which contains the maximum count. I hope you understood the approach, how we are dealing with the sliding window technique here, and how the variables are declared, and why we are using set here to check for the vowels in it. Fine. How sliding window is helping us? Let's brush up here. Because instead of counting the vowels in every substring from scratch, for example, if you have a string here A, E, C, D, E, F, G, fine. I is here. Now K is 3. So from I you will go till K minus 1 here, right? And you will check. That is good. That is fine. But again, you will remove I from here and place I here. And again you will go for K. Right? So it is a tedious task. Assuming it to be a person who first stands here and runs till C. Okay, he calculates the vowels. Again, that person runs back to E and resets the count and again runs till D. And again, that person runs from D, comes to C and runs till E. So the person is going again and again and coming back again and again. And this is a basically iterative thing. And this makes the complexity to be n into k, right? So to remove this complexity, we are using sliding window to O of n, because if you can remember our intuition and approach, we were just sliding the window from left to right instead of going back again and coming forth again, right? And we only update when elements enter or leave the window, making the solution much more efficient. Generally, whenever a value enters or a vowel, we increment the count that time only, right? And if the value, if the vowels is getting thrown out of the window, then we decrement the count. So this makes our tasks a hell lot of easier to complete rather than following n into cross n into k complexity to O on n complexity. So I hope you understood the approach and why we are using the sliding window in this case. Now let's move to the next slide. The code is the exact copy of the approach discussed. Now let's understand it line by line. We have created a set containing vowels. The space is O5. We take count variable to take the current count. N is the length for the iteration. Here we have taken the base case as I explained you. If k is greater than n, we will return 0 because it is not possible to count. Then this is our first iteration for the edge which we take, which makes our task much more easier. This helps us to create the first window and calculates its vowel so that when we start with the next window, it makes it easier as we will having the count of the previous window already, right? So this is the thing which you are doing. Then result will store the count. Till now, the count which we got from the first iteration will be the maximum itself, right? After that, we start I from k till n, from here to n. With the current character, we take the current character and we take the left character, which is I minus k. As I said, if I am standing here, I minus k will be zeroth index. Now I am checking here if the left character is vowel, we have to decrement the count because it is getting thrown out of the window. And if current character is a vowel, we increment the count because it has been getting entered in our window. And at the end, we take the maximum and we return the result. So the time complexity for this problem is O of n. And why? Because this loop goes till O of k and this loop goes from and this for loop goes from uh, O of n minus k, right? So k gets minus, and we get O of 1 as the output as a time complexity, and space complexity is O of 1. Even we are using vowels in this case because the space which we are using is constant and it is not variable. First thing. That's why. And second most thing, time complexity of searching in vowels is O of 1 time in average case, right? So using vowel makes it more optimized, and yeah, that is the reason we are not including space complexity for the vowels here. I hope you understood this solution and the code. Now let's move to the next slide. Now since we have the understanding of the code, let's look at the dry run of the example. Leet code. Okay, leet code. Okay, k is 3. K is 3. Okay. First, our condition was to check if k is greater than n or not. It is not because n is of 1, 2, 3, 4, 5, 6, 7, 8. Because n is of 8 size and k is of 3 size. So this condition gets falsified, right? Okay, this is done. Now we have also created a set of vowels. A, E, I, O, U. Fine. And our first iteration was from I0 till K. Let's mark the indexing also. Let me mark the indexing. 0, 1, 2, 3, 4, 5, 6, 7. Okay. Now I starts from here. It goes up to I less than K, which means it will go up to 2, right? I come still 2, and total number of vowels still here is, let me write here, count, and result will be 2 for the initial case, because for first window the count and result will be same, right? And after that this is done, right? I is standing at E. Now I will start from K. It goes from I equals to K to less than M. Great. So I is standing in T right now, and our formula was to check for left character, right? Left was string of I minus K, right? And current character was S of I, and left, if is in left in vowels, we increment count plus plus, right? And if current character, the current character was in vowel, we increment count plus plus. Sorry, if left is in vowel, right? So we have to decrement the count because we will be throwing that out of the window. This is n. Okay, now I minus k. I is 3, k is also 3. So it gives us 0. So S of 0 is L, right? L. Let me write that L here only. It is L, fine. And S of I is T. Now, if you could see, neither L nor T, both are not vowels. So count will be as it is. Till now, the count is 2. It will be 2, and result will also be remain 2. Okay. Now, Uh, Now we have I got incremented from T to C here. I is in index 4. So 4 minus 3 gives 1, which is E. And S of 4 gives me C. Now, as you can see, E is a vowel, right? So if we get left in vowels, yes, we have E in our vowel. So count will be decremented. So count will become 1. And C, the upcoming character is not a vowel. So count will become 1. And result compared to count, 2 is still maximum than 1, right? So it will be 2. Fine. Now we move ahead. Now I comes to O. I is 5. 5 minus 3 gives me 2. But we have an index to E again. And as of 5, we have O. If you can see, we're throwing out the vowel in the left. So count will be decremented to 0. But simultaneously, we are putting 0, which is also a vowel, into our window, right? So it is in vowel. So count will be incremented. So at the end, the count will remain 1 itself. Okay. Now we moved I to D. If you say 6 minus 3 gives me 3, which is T. And here it gives me B. Both the characters are not vowels, so count variable won't get touched, and result will be 2, the maximum which till now which we have. Again, I moves from B to E as seventh character, the last index. So if we can see seventh character, 7 minus 3 gives me 4, and S of 7 gives me E. In fourth index, we have C. So we can see that we are not throwing any vowel out of the window. So count won't be decremented. But we're getting a V, which is a vowel, into our window. Count will be incremented and count will become 2. And when we compare result and count, who is the maximum? Still 2 is there. So no one is maximum and result has a 2 at the end. And we return 2 as our output, as you can see, right? So this is a dry run. I hope you understood it. Now, if you have any doubt or confusion about the solution we arrived at and how we arrived at it, I would suggest you going back and understanding the intuition and the sliding window concept and the approach and the code. After that, do a dry run by yourself on 2, 3 examples, and I'm pretty sure you will understand both the solution and the thought process behind it. Now let's move to the next slide. Now, since you're familiar with the problem and solution, let's move to the lead code and code the solution. First, we will create a set of vowels A, A, E, I, O, U. Then a count variable to store the current count and to store the length of the string. Result to store the maximum output, which is 0. If n is less than k or k is greater than k, we return 0. And this is the first for loop is for taking the k window size for the that makes our n edge. Right? We count the first window vowels initially if s of I in vowels will increment count, and we'll update the result with count. After that, for I in range, we will start it from k and we will go till n. The left character will be s of I minus k, and current character will be s of I if left character in vowels. If we have the character in vowels set, that means we are throwing it out, will decrement. And if current character, it is also in vowel set. So you have to increment it because you're taking it inside our window. And result will have the maximum of result and the count. And we will return result. Now let's submit and see the solution. Okay, we passed the all test case here. Now let's submit it. I successfully submitted our solution and all the test cases has been passed. Now code of the problem is available in my GitHub repository. You can find the link in the description. Thank you everyone.